Assalamu alaikum. The previous class we discussed about the human eye, the defects, the power of accommodation, the various corrections for the defects like myopia, hypermetropia. Now we'll be going for certain applications of the refraction of light and certain things that use this kind of application inside them, in which we'll be going through the prisms and the scattering of light in the sky. So, first of all, I want to tell you something about the nature of light. As we all know that light is an electromagnetic wave, so it's an energy which travels in the form of wave. When it travels, there is a certain range in which we can see the different colors in this universe, and the rest of the ranges we cannot see, and they are out of our sight. So, uh, the first color is the violet, indigo, blue, then it's a green, yellow, orange, and a red. This band of color that we can see is known as the visible light. And visible light is the obviously it is a visible range that we can see. Rest of rest of the ranges are not visible to our eyes. So this whole spectrum of colors is known as the electromagnetic spectrum of light. So light travels in waves, and these all the ranges travels along with it. Particular Every particular color inside the visible light has a particular frequency, has a particular wavelength. Starting from the violet color, the frequency goes on increasing from the violet color, and for red the wavelength goes on increasing towards the right. So we'll say after violet color the frequency increases, and after the red color the wavelength increases. And all the colors have a particular wavelength. So starting from the violet color, the wavelength is from 400 nanometers to the red color, it is 700 nanometers. So we can say that the wavelength of red color is the highest. Now after the red color, the range that comes is the infrared range, and violet, the range after violet is the ultraviolet range. And there are so many different kinds of waves in these ranges, that is, we can say the radio waves, the microwaves, which we cannot see, but the only range which is visible to us is this visible light. So this particular range of light is the visible light. Greater the wavelength of a light, particular color, greater will be its speed. So we can say that the that violet color will have the slowest speed if it gets refracted inside a medium, while as red color will have the greater speed and will travel at a greater speed if it gets refracted through some medium, which we'll be discussing in prisms. So Newton wanted to check the nature of the white light. When the white light that comes from the sunlight, that he wanted to check what is the nature of this white light. Is there something else inside this white light, or is it just pure? How are we able to see things then? And what happened? He let a narrow beam of sunlight, pass through a slit, and what he did was that he kept a prism in the midway of the beam. What happened? He could see, and he kept a white screen to check what sort of is there anything that is inside this white beam of light. So what happened? He could see that while this white beam of light struck the prism, it got dispersed into seven colors, in which just drawing the spectrum. So he could see this band of light on the white screen. This was the screen he kept to check the nature of the light, and he could actually see that red color was the first to come out, while as this was the last, because red has the higher wavelength, which is denoted by lambda, while as the frequency of the violet color was the greatest, so the speed of it was slower. That is why red color was the one to be scattered first. So what is the conclusion? We came to know that if we keep a prism like this and we let a beam of light pass through this prism, say we keep a cardboard piece here and make a slit through it and let a white light, say torchlight or sunlight, pass through it. After passing this white beam of light on the prism, it it will get scattered into seven different colors, known as the dispersion of light, that we'll see why. When the light will strike the first inclined surface of the glass prism, this is inclination 1 and inclination 2, what will happen? It will try to bend towards the normal, since we know when light rays goes from the rarer medium, that is air, to the denser medium, that is the glass prism, it bends towards the normal. So since red has higher wavelength and its speed is greater, it will bend, but it will bend the least towards the normal. Then the most bending of light rays will be of the violet color. It will bend the most towards the normal, and since after striking the other inclination of the prism, they will individually get dispersed in different ways. Like red will be getting, say we have normals like these, and we also know that after after the light goes from the denser medium to the rarer medium, they bend away from the normal. So we can say red will go away from the normal, sorry, and similarly violet will. also move away from the normal, and there will be other colors in between them that will be showing. There you go, to the blue, green, yellow, orange, and red, having maximum wavelength, will spread the most. So this is known as the dispersion of white light through a glass prism. This is what Newton proved. So the white light coming from the sun or white beam of light coming from any other object doesn't mean it's just that one color. It contains these colors that come inside the visible range, and our eyes are only sensitive to these colors of light. Assalam.